that we have to differentiate functions. And here you see that, well, the chain rule or the differentiation rules plus chain rule is what you need to know. For example, for the first one, we have the derivative of u to the power n in general is n u to the power u prime u to the power n minus 1. In other words, f prime x is going to be n here is 10 times the function there minus 4x cubed plus 3 prime and u prime, then u to the power 1 less. So that will give me 10 times derivative of this polynomial. This is 4x cubed minus 12x squared plus 0 times x4 minus 4x cubed plus 3 to the power 9. The second one, you might say that, oh, where is the power, or how can I use this? This is basically e to the power x plus 4 sine x to the power 1/3. And then f prime will be n, which is 1/3, times derivative of the function there, times the function e to the power x plus 4 sine x to the power 1/3 minus 1. And that gives me 1/3. Derivative of e to the power x is e to the power x plus 4 times sine. The derivative is 4 times cosine x. And then e to the power x plus 4 sine x to the power -2/3. You can simplify a little bit, but that's what we have there. The third one, you can write that function as, that's the same as this one, some function to the power -4. So f prime x will be -4 times derivative of that function times the function to the power 1 less than the original power. So that will be -4 times 2x plus derivative of e to the power x is e to the power x. Derivative of cosine x is minus sine x. And then you can see that this is -5. I can take it down and write it as x squared plus e to the power x plus cosine x to the power 5. This one is, you see, derivative of cosine of something is first derivative of that something u prime times derivative of cosine, which is minus sine, but evaluated at that given inner function. And that will be x, oh, that minus I can multiply, you get minus x squared. Oh, I have to differentiate, sorry. This is 2x minus cosine x times, well, I don't need to put any bracket anymore. This is already differentiated. Sine of x squared minus sine x. There's a minus sign that I put it up front. And this last example, I like this last example because when you do differentiation of composition of two functions, you don't see why people call this thing chain rule. But when you have more than two functions, like f evaluate composed with g, composed with h, then you notice why it is called the chain rule. If you apply chain rule twice, you notice that this will be the derivative of the very inner one times the derivative of second inner one evaluated in the very inner one times derivative of the outer one times evaluated at two inner values. You see, it's like chain. You're getting one by one from inside toward outside. You differentiate inner one, then the second inner one, the third inner one, and so on. Here, to see that how this works, I will do this one by one. So this is cosine of something. So the cotan of something. So the derivative would be that derivative of that something times derivative of cotan. This is minus cosecant squared evaluated at sine squared x squared, sine of x squared. Yeah, there's another bracket. Now, sine of x squared itself needs a chain rule. So it will be the derivative of the inner one, which is x squared. You differentiate that times cosine, the derivative of sine is cosine, evaluated as at x squared. I will put minus down there, cosecant squared sine of x squared. And what derivative of x squared now we know it is 2x. So chain rule is what you need to know. Derivative of composition is derivative of inner one times the derivative of outer one evaluated at the inner